Hey everyone, it's John, and today what I'm going to do is do a video on best practices for NSAP addressing in ISIS. So if you remember from the previous video, we had this topology here. Now the difference was, in the first video, the loopback had a simple configuration of, if for example you were router 1, the loopback would be 1.1.1.1. If you were router 2, you would be 2.2.2.2. If you were router 4, you'd be 4.4.4.4. Now, this isn't a very realistic configuration. You're more likely to be using private IP addressing, or you should be doing that. So in this case, we've now changed the loopbacks to a format of 10.1.250.x, x being the router ID, so router 1 would be 10.1.250.1, router 5 would be 10.1.250.5, router 6 would be 10.1.250.6, so on and so forth. You get the idea. Now, the reason why I'm focusing on loopbacks is the best practice for ISIS, configuring the system ID part of the NSAP address, you pretty much base it on the loopback. Now that's going to be, you need to do a little bit of manipulation to get that right, but I'm going to show you the practice to get that done. So what I want to first do is just a quick revision on the NSAP address, and then we're going to kick on how to do it with this loopback configuration, okay? So if you remember from the previous video, we would have an address something like this. It would start with 49 always, because this basically denotes it's like a kind of private IP address, like see the way you do a 192.168 type address or a 172.16. For the OSI model, 49 would be indicative of a private IP address, or not an IP address, a private address. So this would always be 49, okay? The next part would be your area ID. So in the case, the format we were using, for example, if we had area 1, we were doing 0001. If it was area 2, it would be 0002. Area 3, 0003. So area 1 would be, like I said, would look like this. 1. And this part of the address is our area. Okay. Now, the third component, and this is the important component for this one here, this is going to be 12 digits long, and in the previous video we had tied that to the loopback, but it was very, very simple. So for example, if we were router 1, our loopback was all the ones, so we just made 12 ones, so it'd be 1111.1111.1111. If it was router 4, its loopback would be 4.4.4.4. So our system ID would be 4444.4444.4444. Okay, now you can probably imagine that that wouldn't scale well. So first off, what I'll do is I'll just do it for router 1. So the way it was looking previously was 1 1 1 1 1 1 1 1 1 1 1 1, and this part was the system ID, which had to be unique. And the last part, like I say, would always finish with .00. That's just basically denoted that you were talking to a router. Okay. So even though this looks like a complex address scheme, you're always going to start with 49 and you're always going to end with .00. The two ones which matter are this one, your area, and then your system ID, which has to be unique. Basically going to denote you're going to put one for each router. So the practice here is we're going to use the loopback address to make this part here a little bit more scalable, because if you think about it, we just basically copied all the ones. We had 9 routers, so we could get away with that. We could do 1 1 1 1 1, and then if it was 8, do all the 8s. If it was 9, all the 9s. But let's say we had router 11. Now suddenly this is going to start looking weird, because is this router 11 or router 1? It's not very clear anymore. Do you know what I mean? And clearly, if you're dealing in the hundreds of routers or thousands of routers, then this gets even less manageable. Okay. So what I'm going to do is discuss the way you would convert your loopback address into a format which would be ideal for this type of addressing. So let's say we had the address, a loopback address, okay? This is not the loopback we're using, but just for example, let's say we had this address. We had a loopback of 192.168.56.4, and it was a /32, okay? How would we get that into that system ID? Well, here's the thing. You want to break each octet so that each one has 3 values. Now, if they don't have 3 values, you use leading zeros. So clearly, number 1, that already has 3 values, so we can leave that alone. 1, 2, 3. That's the first part. The second octet also has 3 values, so we can leave that alone. 1, 6, 5. Now, the third octet only has 2 values, so to make it 3, we're going to use a leading 0, so it's going to be 0, 5, 6. And the last octet only has 1 value, so to make it 3 values, we need 2 leading zeros, so it'll be 1, 2, 3. So this is the first part of the conversion, okay? We basically make sure that we've got 3 values per octet. And then, this might seem a little bit strange, but because of the actual format, it's going to be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We're going to have to break these into 4s, okay? We're going to have 3 groups of 4s, so effectively, what we're going to do here is break a line down here. So we've got a group of 4 here, 1, 9, 2, 1. And then we're going to break another one here. It's a little bit messy, but you get the drift. And here, okay, so that's a bit messy, but you can get the gist of what I'm trying to do here. So effectively, what we now have is we have a 1, 9, 2, 1 dot 6, 5, 0, 5, 6, 0, 0, 4. And this here is going to be our system ID. You see, it's 12 digits. And you can actually look at it, it's corresponding to the loopback. 192, 165, you see the leading 0, 56.4, and that is effectively pairing with that loopback up here. Does that make sense? So let's do another example so we can just get this clear in our head. Let's say we've got a loopback of 172.16.1. 31/32. So like I say, we've got to convert each octet so that they have 3 values. So 172 again has got 3 values, so that's just the same. So 172.16 only has 2 values, so we'll put 1 leading 0, so we'll do 0, 1, 6. The third octet only has 1 value, so we need 2 leading zeros. So we'll do 0, 0, 1. And the last octet has 2 values, so to make it 3, we add 1 leading 0. So there we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now we split them into 4s again, so we draw the line here. We draw the line here and the line here. So this now becomes 1720 dot 1600 dot 1031. Okay, so the final address would be look something like 49 because it's a private IP address. Let's say we were in area 2. Would be 0002, and then it'd be 1720 1600 1031, and always end with 00, and that's your NSAP address right there. And that was derived from the loopback of this, and that's a much more scalable way to do that. So that's what we're going to do in this video. It's going to be quite short. We're just going to configure it and rattle through it. I'm not going to touch too much on the theory of level 1, level 2s. I'm going to go a little bit more into that again when I talk about design, but for this video we're just going to do that. So clearly if we look at our loopback formats, it's going to be quite repetitive because we've got a really kind of particular format here where they're all kind of following the same. So for example, let's just do router 5. So we can see router 5's loopback is 10.1, I think it was. 250.5, is that correct? 10.1.250.5 is router 5, okay? Just write that here, R5. Okay, /32. So again, make each octet have 3 values. So the first value only has 2, so we'll make that 3 by putting a leading 0. So that's 0, 1, 0. That's the first one. Excuse me. The next one only has 1 value, so we go 0, 0, 1. The third one has 3 values already, so we just leave that alone. And the last one only has 1 value, so we use 2 leading zeros. Now we break that into 4s. There we go. And we now have this address of 0100 dot 0125 dot 0005. And again, we just do the same thing by making it 49, and router 5 is in what area? Router 5 is in area 2, so of course we're going to use 2 here. Be 0002, and then pop in that system ID, which is 01000125 0005, and always end with the 00, and that's the NSAP address right there. And that's all you need to do. So let's just quickly go through the configuration, and we'll just do it just now, okay? So let's go. We'll do configure terminal router IS, and we'll do IS type level 1, 2 for our ABR as we're calling it, and we'll do net. Now here's the part we need to get. We do 49 and we're in area 1, okay? So we're going to do 0, 1, 0. In fact, you know, I'm better write this down to make it simple so it's easy to follow, okay? So raise that. So in this case we're going to be 0, 1, 0, 0, 0, 1, and 250, I think it was, isn't it? 1 and so we're going to have the address of 0, 0, 1, 0, 0, 1, 2, 5, 0, 0, 0, 1, and that's our system ID part there. That's the 12 digits, okay? And that's it. And then just as like we did in the last one, we would just go into do our interface configuration. So we've got what gigabit 00, 01, 02, 03, as well as the loopback. So we just do int range gig 00 to 3 IP router IS, and that's it. And that'll be that. So maybe we'll just do another couple. Don't need to do them all, mind you. So we'll do router 4. We're going to do conft router IS type level 1 to net, and again it's going to look pretty similar, but it's going to end in a 2 this time. 49, and we're in area 2 this time, so we're going to see area 2, and then we're just following the same format. So it's going to be 0, 1, 0, 0, 0, 1, 0, 0, and 0, 1, 2, 5, 0, 1, 2, 5, 0, 0, 0. In the case of this one, it's going to be 4, and that's it. And then just put in your interfaces. So int range gig 00 to 2 IP router IS, and int loop IP router IS. Maybe do a couple more just to finish off. This is router 3, router IS type, and this was all just a level 1, and the net is going to be 49, and we're in area 1 here, so 100, 0125, and we are on router 3, and we're going to do 00, and int range, or not even the range, it's 1 here, isn't it? Gig 02 IP router IS, and loop 0, and loop 0 IP router IS, and we'll just do 1 here, router 5, that'll be us. You kind of get the drift at that point. Keep this video one a bit shorter than usual. So we'll do IS type, level 1 this one is, and net is 49 of course, and we're in area 2, so we're going to do 0100, 0125, and we are on router 5 this time, and 00, and int gig 02 IP router IS, and loop IP router IS. Do our show IP routes. Give a little bit of a time to fix this. Okay. Okay, so that's us got our relationships up. Yep, so that's all fine. All good, all good. Okay, so like I say, with this video, I don't want you to get too bogged down and getting confused at looking at this address all in one. Like I say, see when you look at that NSAP address and you just see the numbers, just 49 and blah, 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 blah. Break it down into 4 chunks. You always remember, we're always starting with 49, we're always ending with 00. Then we've got a wee area ID, and then we've got this unique system ID. This system ID, as long as it's unique, you're all good. And like I said, the easiest way and best practice way to derive it from the loopback address, and the way I do it, the way it's common to do it, is to use leading zeros to make each octet have 3 values. Then you split that into blocks of 4, so you have 3 blocks of 4, and that becomes your system ID. After that, you're good to go, and that's all done. Okie doke. So that's the end of this video. I'm going to keep it trying to keep it at least a bit shorter than the last few. Last few have been kind of 20-30 minutes, so hopefully it's less than that, hopefully. And the next one I'm going to do is going to be on IS design. Okie doke. So thanks very much, and I'll see you guys soon. Bye bye.